This is Geometry, Semester 2, Lesson 7.5, Proportions and Triangles. So this lesson is split up into two parts. We're going to talk about the side splitter theorem first, and then the triangle angle bisector theorem second. So let's talk about the side splitter theorem. Okay, so when we have two or more parallel lines that intersect other lines, we get these proportional segments that are formed. And so that's where the side splitter theorem comes from. We've got this triangle here, and the base is parallel to some line that cuts through. You can see that. And when that occurs, these sections that are made, so here, that's our QR to our XR, these two parts here on the left are proportional to these two parts over here on the right. And this is true for any triangle that's cut by parallel lines. And so what we're going to be able to do is set up these proportions of these corresponding parts. So we're going to start here. It says, what is the value of x in the diagram on the right? So you can see we have an x on the bottom left and on the bottom right. And so we're going to set up this proportion. Okay, so side splitter, those ratios, we're going from parts on the same side. So I've got this 12, so I'm going to take that 12. So I've got a few choices. If I'm going to follow the basic syntax of that side splitter, I'm going to set it up to the other part on that side, x plus 1. And I'm going to follow that same kind of order on the other side of the triangle with the parts, my 9 and my x. So I go 9 over x. And now I've got a proportion that I need to solve for x. And once I finish solving, I will be good to go. So I multiply my cross products like what we've been doing. Remember that x plus 1 is a quantity. So I go 12 times x gets me 12x equals, well, x plus 1 times 9 is 9 times the quantity x plus 1. Be careful that you take that 9 and you distribute it to both terms. Those are the biggest mistakes that we see on questions like this one. So I distribute to both. I get a 9x plus 9. And now I just want to start moving stuff around to solve for x. I notice it's just linear, not a quadratic, so I just want to bring the x's to one side and the constants to the other. So I'm going to bring that 9x over as a negative. 12 minus 9 is 3. X equals 9. I'm going to divide both sides by that 3, and x is 3. And we're good to go. So it's that simple. I'd like you to try this next one. It says, what is the value of a in the diagram at the right? So pause the video, set up your proportion, and then check it with mine. All right, we can see that proportion now. To check ours, if your proportion is slightly different, just check our cross products to see if we're multiplying the same things by each other. And then, once you get a equivalent proportion, you can solve it on your own again and then check your work with mine. So pause the video again and try to solve this. Alright, so you can see my work of how I set up those cross products. I distributed, I balanced, I divided, and I ended up with a being equal to 8 in this case. So that's just your basic side splitter theorem. The side splitter theorem can be applied to things that are not just triangles, and so we have this corollary that allows us to do a little bit more. So it says that, hey, if I have 3 parallel lines to begin with instead of a triangle, if I have 3 parallel lines there, A, B, and C, it cuts the chunks into proportional chunks. So from A to B and from B to C is proportional to WX to XY, as you can see right there. Okay? So it's kind of nice because it allows us to solve problems like this next one here. It says 3 campsites are shown in the diagram. What is the length of site A along the river? So we've got a river, we've got a road, we've got 3 sites A, B, and C. So site A is here, and then along the river, we don't know. I'm going to call that X. Okay, so what we want to look for when we set up that side splitter theorem are, do we have parallel lines? And so I do. I've got parallel lines here, here, and here. And then we want to look for, okay, is there 2 parts that have numbers and not just variables? So in site A, I don't have the river length, but I have the road length, which is helpful. Site B, I have the river and the road length. So I'm going to use site A and site B together. So I'm going to start setting up a proportion again. So I've got this X along the river. I want that to go along the river to the other site because these are this is basically a turned, rotated picture from the theorem. Okay, and so we've got X. I want it to go to the other river length, 8. So I go X to 8. And I've got this site A is on the top, so I'm going to do site A on the top as well. And then to my B length of 7.2. And now I've got a proportion that I can multiply my cross products and solve. So I go x times 7.2, I get 7.2x. 8 times 9, I get 72. Now I just got to finish getting that x by itself. I divide both sides by 7.2. And x, type that in on my calculator or do it in your head, and you should get x to be equal to 10. Now we introduced 10, so we want to make sure we put a label with that. I don't really care that it's x. What I care is it's the river length. And I look at the units in my picture. Everything's in yards, so I say it's 10 yards. Now I'm going to ask you actually to do a bonus question real fast. We've got site A, B, and C, and over in site C we're missing the road length here, so we don't know how much that is. Let's call it Y. I'd like you to set up your own proportion and solve for that one, so I'll have you pause the video, set up your proportion, and then you can check your proportion with mine, then you'll pause again and solve. So pause the video, here's your picture, and try to set up that proportion. Alright, you can see in red there my proportion that I set up. Yours could be slightly different, but you should have the same cross products as I do up there. So double check yours, make sure it's the same as mine. If not, edit and adjust it. Now pause the video and try to solve that. Alright, you can check your solution with mine. I got 5.76 yards. And that's everything to do with the side splitter theorem.